Hi everyone. In this video, I will give a brief overview of primitive and composite data types in processing. Understanding these data types and when it would be sensible to use each type is an important skill for using real-world data in our programs. Using these, it is possible to create even more complex types, which we refer to as data structures. Data structures allow us to build software that matches our most complex problems, allowing us to solve them more easily. There are many different types of data and many ways to represent data in a computer. In programming languages, including processing, we typically need to state what kind of data we are working with so that the program knows how to store and use it. Is it a number, a character, a string, or is it something else entirely? This is known as defining the data type. Processing has several primitive data types, so called because they are the most basic form of data that can be stored and used within a program. Whole numbers, numbers with no decimal point, are represented as integers and store values such as 0, 1, 2, -6, 285, 1094, and so on. In processing, we use the special word int in front of a variable name to tell processing that it's an integer. If we wanted to define the age of a person in years in processing, we'd use an integer value, as it's a whole number. To do this, we'd write int age equals 30 to represent an age of 30 years in the variable called age. Decimal values are also known as floating point numbers, and they're represented using the processing keyword float in our code. We use a float variable to store a number with a decimal place, such as 1.2. If we wanted to represent the proportion of red apples in a bag of red and green apples, we could use a floating point number because proportions are decimal values. To do this, we'd write float red apples equals 0.4, which we'd use to represent that 40% of the apples are red. Processing also contains a data type that holds true or false values called Boolean. If we wanted to store whether someone has travelled overseas or not, where they either have or they haven't, we could use a Boolean. To do this, we would write Boolean travelled equals true, to show that the person has travelled overseas, or Boolean travelled equals false if they have not. Individual letters or characters are indicated by the processing keyword char, and are values such as A, B, and C, as well as special characters like plus and ampersand. Any single character value can be a char. If we wanted to represent the first letter of the name Frank, we can use a character to represent that letter, writing char first letter equals F. It's important to note that the char must be encased in single quotes, and that chars distinguish between lower and uppercase. Using these primitive data types, it's possible to create more complex types called composites. An example would be combining multiple characters to create a word. In processing, we can use an existing composite type that is called a string. It's important to note that the S in string is a capital S. This will let processing find the right string to use for your programming. We could represent the name Frank as string name equals Frank. Note the use of double quotes here, which tell processing that we wanted to store a string, a series of characters, while the single quotes are used for individual characters. We can go further. For example, if you wanted to have multiple integers or floats, rather than storing them in individual variables, you could store them consecutively in a useful container that collects together several variables of the same type under one name. This is addressed later in the course. When we get there, this useful container is called an array. Thanks for watching. I'll see you later.